Something is wrong with the sky. Not wrong like a cloudy night or a misaligned telescope. Wrong like a star is doing something that should be physically impossible. Elena Vasquez had been mapping stellar motion for 11 years. She knew how stars moved. She understood the gravitational dance, the predictable arcs, the math that governed every single point of light in the observable universe. So when she flagged the anomaly on a Tuesday morning in her cluttered observatory outside Tucson, her first assumption was equipment failure. It was not equipment failure. The star, cataloged under the forgettable designation HD-7741, sat roughly 340 light years from Earth in the constellation Sephiius. On paper, nothing remarkable. Medium brightness, estimated age around 4 billion years, no known companion objects. But over 18 months of observation, something deeply unsettling had emerged in the data. HD 7741 was accelerating, not drifting, not following any gravitational curve Elena could identify. Accelerating in a direction that contradicted every force acting upon it. Stars do not do this. She ran the numbers 3 times. She asked a colleague in Germany to independently verify using completely separate equipment. She submitted her preliminary findings anonymously to 2 different astrophysics forums online just to stress test the math. Every verification came back with the same uncomfortable answer. The data was clean. The star was wrong. Now here is where it gets genuinely strange. When Elena began backtracking archived telescope data, she discovered HD 7741 had appeared completely stationary for decades. Normal. Unremarkable. And then approximately 6 years ago, almost overnight in astronomical terms, it began its impossible motion. Not gradually, suddenly. The physics community offered several competing explanations. Some proposed a massive invisible object, perhaps a rogue black hole outside current detection range, generating gravitational pull strong enough to account for the acceleration. Unconfirmed. Others suggested the star might be interacting with dark matter concentrations in ways current models cannot fully predict. Also plausible. Also unconfirmed. But a smaller, quieter group of researchers pointed to something the mainstream voices were reluctant to discuss openly. The acceleration pattern was not random. When plotted across 3-dimensional space, HD 7741 was moving with what appeared to be remarkable geometric consistency. Almost deliberate consistency. The kind of trajectory that, if continued, would bring it noticeably closer to our solar system within approximately 200,000 years. That sounds like a long time. Cosmically speaking, it is essentially tomorrow. Elena published her full findings in March of 2025. The paper drew significant attention and significant skepticism in roughly equal measure. She has been careful in her own public statements, refusing to speculate beyond what the data directly supports. But in an interview she gave last autumn, she said something worth sitting with. She said that in her career she had learned to trust the math, even when the math made her uncomfortable. The math right now is very uncomfortable. We do not know what HD 7741 is doing or why. We do not know if any current model can adequately explain it. What we do know is that the universe just handed us something we were not expecting, and that, historically, is exactly when science gets interesting.